A very warm good morning to one and all present over their class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will discuss some questions or some theory related to three-dimensional geometry, and topic is plane. So today we have calculate or we will derive the formula of equation of plane in normal form. So see, equation of plane in normal form. Equation of plane in normal form. Equation of plane in normal form. So let us consider a plane. Suppose this is the plane we are considering this point capital A, capital B and capital C. So this is Z positive axis, this is X positive axis, this you can consider C, and this is B. A plane as shown in figure which intersect X axis at a point A, Y axis at a point B and Z axis at a point C. Now we have to calculate this equation. So first of all we will consider, let a plane ABC a plane as shown in figure plane as shown in figure whose perpendicular distance from the origin whose perpendicular distance from the origin you can consider that is D. Suppose from the origin we are going to draw the perpendicular on this plane. This is the (90°). This is D. And now suppose any other point P, any other point P having coordinates x, y, z, consider its coordinate we are going to consider x, y, z, and this is the point, consider Q. You can consider this is normal, so this you can consider also ON also. Now we can say such that distance d is not equal to 0. This is the condition. Distance d is not equal to 0. So from figure, ON is the normal from origin to the plane. From figure, ON is the ON is the normal drawn from origin to the plane, and n cap is the unit vector, unit normal vector along ON. Unit normal vector along ON. Along ON. You can say ON vector. Then ON is vector is equal to vector ON vector. What we can write? This is the unit vector. This is small n, and d is the distance. So ON we can write unit vector into d, or d into unit vector, or d into unit vector. So consider equation 1. And from figure, it is clear OP is equal to R. OP is equal to, this is R vector. From figure, OP is equal to R. See, means the position vector of point P with respect to origin, that is OP vector. OP vector we can consider vector R, and R is equal to xi plus yj plus zk. See, this is equation 2. If any doubts, can clear it. Now from figure, what we can say? See, from figure it is clear ON is perpendicular to every line which lies in that plane. Means there are so many lines you can consider in this plane, and all lines will be perpendicular to this line ON. So we can write, since ON is perpendicular to all the lines, lies in plane. So one line is Pn also. So what we can say? From figure, ON dot NP. ON dot NP. What we can say? Then vector ON or dot NP. What you can get the result? Result you will get 0. Because ON is perpendicular to OP. Here we can write ON vector is perpendicular to NP. NP vector. So ON dot NP result you will get, that is 0. So NP, what we can write? And ON, what we can write? See, NP vector, ON as it is I am writing, and NP vector we can write OP minus ON. OP minus ON. OP vector minus ON vector, it's equal to 0. So ON we have considered, this is unit vector, and this is unit vector into what we can write? NP or OP. OP vector we can write vector R minus this vector we can write N dot D also. See, N dot D. So this one what we can write? See, this one we can write means vector N unit vector or R minus N dot N vector into D is equal to 0, and I dot I not cross is equal to 1. So this result will be 1. So this one commutative property with respect to multiplication or dot product verify. So R vector dot a unit vector N minus this result will be D is equal to 0. So vector R dot vector N unit vector is equal to D. This is the equation of plane whose perpendicular distance from the origin is D. So D is the perpendicular distance, D is the perpendicular distance, and N is the unit vector along ON, where D is perpendicular distance from origin to plane. Now this topic is totally completed. Now I will come to the next topic. The next topic is the next topic is this is the equation of plane in a vector form. This is the vector form of equation of plane. Now equation of plane in vector form. Equation of plane in vector form. So see, that is r vector dot unit vector is equal to d. Now we are going to convert in Cartesian or normal form. So you know, since vector r is equal to OP from figure, OP is a vector and its measurement is vector r, and this one we can write in terms of Cartesian xi plus yj plus zk. This is the Cartesian form. And now unit vector. Suppose let small l, small m, small n is the direction cosines of vector n, unit vector n we can consider. So what we can say, that is unit vector n we can write Lx plus my plus nz, Lx plus my plus nz, or Li in terms of Li we can write Li unit vector plus mj plus nk. Now r dot n is equal to d, you know, r dot n is equal to d. Consider this is 1 and this is 2. So r dot 1 is equal to r dot n is equal to d. Multiply equation 1 and 2. So xi plus yj plus zk dot li plus mj plus nk is equal to d. And when you multiply, so what you will get the result? This result we can write Lx plus my plus nz is equal to d. So this is the equation, Cartesian equation of plane in normal form. Cartesian equation of plane, this is in normal form. And we can change also Cartesian equation of plane in direction ratio also. So what we can write? See, this is the Cartesian equation of plane in normal form. Cartesian equation of plane in normal form. Now see, Now I will come to the next. Heading C. Now suppose let capital A, capital B, capital C are the direction ratio direction ratios of unit vector n, direction ratios of vector n or on on vector. So what we can say, this equation Lx plus My plus Nz is equal to D. We can change in terms of Ax plus By plus Cz is equal to D. This is the Cartesian equation of plane. So this is the vector, not vector OM. This is the Cartesian ratio, direction ratios of the normal to the plane. Direction ratio of the normal, suppose of the normal to the plane. So this is the equation of the form always represent the plane, and this is the Cartesian ratio also. So Cartesian ratio, not direction ratio. Now how to reduce the Cartesian equation to normal form? How to reduce the Cartesian equation to normal form? And this is the Cartesian equation and normal form. How we can change? Keep the terms containing x, y, z on LHS and a constant d on RHS. We have to set x, y, z terms in LHS and d terms in RHS, constant. And if the constant on RHS is not positive, if the constant in RHS is not positive, then make it positive by multiplying both the sides and divide by this under root a square b square, a square plus b square plus c square. Now this one is completed. See, if any doubts, can clear it. Here we can write also, where L is equal to also we can write direction terms, direction ratio or direction cosines a upon root over a square plus b square plus c square also. And m is equal to plus minus b upon root over a square plus b square plus c square, and n is equal to plus minus c whole upon root over a square plus b square plus c square. This is. Now see. Now this topic is totally completed.